Hello, welcome back to yet another episode of Learning with Junaid. Today we are going to be talking about an interesting interview question. The question goes something like this: write a program to sort a stack such that the smallest items are on the top. They will also give you certain parameters. Excuse me. You can use an additional temporary stack, but you may not copy the elements into any other data structure, such as an array. The stack should support the following operations: push, pop, peek, and is empty. A very frequently asked question. So without having to waste any time, I'm using an inbuilt stack of integers. I've populated it with these values. If you see carefully, these values are not sorted. Our job is to sort them in such a way that we have 5 and 9 and 10 and 22 in an order. The smallest element should be on the top. So I wrote a dummy method. We are going to be implementing this method and see how we can do this. Actually, the answer to this question is already in the question itself. For example, they're saying you can use a temporary stack. So we will be using a temporary stack. What we will do is the temporary stack that we use, we are going to be comparing against the values in this stack. If the values in the temporary stack are greater than the values that we have, then we are going to put it into the stack one. Otherwise, we will keep pushing it into a temporary stack. How do you do this? So first, define a temporary stack of integers, and let's call it as a temporary stack. Per se. So now what we will do is we will iterate through our stack 1 dot is empty, that is not. So what do? We are going to pop the element from the existing stack. Let's name this value as int val. Okay. Next, what we will do is, while we are popping these values, at the same time we will maintain a temporary stack, and we will start checking into our temporary stack while my temp stack is not empty, and my temp stack dot peek, just check the value, don't pop it, is greater than this value. So what do I have to do in this case? If the value in my temporary stack, the first time it will obviously have nothing, so we have not inserted anything here. So we have to insert the values into temporary stack. So the first time the temporary stack would have push val. So the check is, you check if the value in the temporary stack, is it greater than an existing value? If yes, then what you do is stack 1 dot push, take the values from your temporary stack, pop it. So the first time the value will be 5 here. So the first time it will not reach here at all. The first time it will put the value as 5. I will debug you and trace it. The second time the value will be 22. Will be 22 is greater than 5, yes, and then it's going to push the value whatever it is, 5. So stack 1 will push the value as 5. So it will continue going through this loop again and again until all the values are been pushed. So once this while loop ends, what you are going to do is you are going to check if my temporary stack is empty, iterate through it and pop everything from your temporary stack and put it into your see stack 1 dot push. So at this point here, your stack 1 would have become empty because you have popped everything out. You have already done all the comparisons, you have already pushed everything. So this would be your temporary stack, which will have everything in a sorted order. So you just iterate through it again, put everything back in your stack 1 and return the stack 1. So let's see how this works. I am going to debug this. I put a debug pointer, let's say here. I'm going to debug it one by one. Okay, so the first time it comes here, you define a temporary stack, you pop the value is 5, yes, okay. It is, this condition won't satisfy, so it's going to push into temporary stack. The next time the value is 22 and temporary stack dot peak will be 5. Is 5 greater than 22? No, so it's going to push it here, 22. Next time the value is 9. When you do a peak on your temporary stack, it's 22. Is 22 greater than 9? Yes. So it's going to pop out whatever was that peak value, 22, and then put it here. So you will have 10, 22. So go through it, same thing again, same thing again, same thing again. So at this point you would have a temporary stack which would have 5, 9, 10, you see. So you would have a sorted, at least the lowest one, the minimum one is at the top. So pretty easy. So as I said, the answer is actually in your question itself. You can use a temporary stack. So all you have to do is maintain a temporary stack, iterate through this, pop the values, compare the value with your temporary stack peak. If they are greater, then pop that and put it into temporary stack. That means, you know, this would have your values that all being popped from a temporary stack, and keep pushing the values into your temporary stack. So at the end you would have a temporary stack which will have your sorted stack, and then finally just iterate through it and pop everything and put it back into your stack 1. So that's how you do the minimum element first in a stack. One thing to notice is, if you see very carefully, the algorithm in itself has O into N2 as the space complexity, time complexity, and O and N for the space, because we are going to be maintaining one variable as we iterate through it. So this variable once, and then you have 2 loops, so it will have n square. It can be further done to improve the algorithm. It can further be better. So I'm going to probably find one more solution and update it, but for now I think this should work. And this is also one of the most frequently asked questions, and the approach that a lot of people would take, including me. So if you have any comments on this video, please go ahead, write a comment. If you have not pressed the like button, please, if you can, press the like button. Also, if you have not subscribed to my channel, please, I would appreciate if you can just subscribe to my channel. Until then, next time if I'm coming to a new video, I will talk to you soon, and see you next time. Thank you.